Right, in this lesson, we are actually going to look at reciprocal function, which is a rectangular hyperbola. Now, by the end of the lesson, you should be able to recognize the critical features of a rectangular hyperbola of the form y equals to 1 over x in terms of the line of symmetry, asymptotes, and the behaviors. You should be able to apply dilation to the rectangular hyperbola, which is y equals 1 over x, and describe the effect on the shape and behavior. You must be able to add vertical and horizontal translation to the vertical rectangular hyperbola, state the domain and range of a reciprocal function, and finally, determine the equation of a hyperbola from sufficient information. Now, let's consider a rectangle with a fixed area of 1 unit square, but variable dimension x and y. So if x is 1, y must be equals to 1 because the area is 1 unit square. So the area is actually 1, and you know that it's x times y because it's the width times the height. If it is 2, you actually have half, and if it is 4, is 1/4. What about if x is 1/5, y is 5, and so on and so forth? Alright? Now, what I'm going to do is going to sketch the fixed area of 1 unit square on the Cartesian plane. So I'm going to start off with just when x is 1, y is 1, which is this point here. When x is 2, y is actually half. X is 2, y is half. And when x is half, y is 2. Ooh, and this is somewhere here. So if you join the 3 points, you actually get a hyperbola. And in this case, you are actually looking at, this is just the positive side of it. So, in fact, because we are looking at area only, we are not using any negative numbers. But you can see that if I have -1, y would be -1 as well, because -1 times -1 is 1. Alright? And then if I have a -2, I have -half. -2 times -half is 1. So, and so on and so forth. Alright? So if it is x is -half, this is actually 1. Oh, actually, no, it's 2. My fault. So therefore, you can actually draw the other parts of the hyperbola. Alright? So now, let's have a look at the definition of a rectangular hyperbola. Now, if you look at a rectangular hyperbola, you can see that we use a rectangle to actually, with dimension of x, y, with a fixed area of 1 to derive the rule of xy equals 1. So it gives all possible dimension, xy equals 1 gives all possible dimension that results in a fixed area. So to write the dimension in terms of an equation or function, we state that y equals to 1 over x, or function of x equals to 1 over x. Alright? So what you can see that this is a function, and if we use the vertical line test, alright, I'm going to use a different color and draw a vertical line. For one x value, you've got one y value. Same with this one. This part, one x value, you've got one y value. So therefore, you know that this is actually, what sort of function is this? Is it 1-to-1 or many-to-1? Alright, we know that it's a function because a 1-to-1 relationship. Alright, now let's look at the critical feature of y equals to 1 over x. First, the line of symmetry. Here, you've got positive and negative line of symmetry. Let me first show you what the positive line of symmetry is. Alright, so if I draw this line here, you can see that if I fold the parabola along this line, you know that this bit here will cover this bit here. Same with this one. This bit here will cover this bit here. So therefore, you know that this is an axis of symmetry or line of symmetry. And we call it positive line of symmetry because the line of symmetry is actually has a gradient, a positive gradient. Right, let me get rid of this because I'm going to show you the negative line of symmetry. So here, use a different color. I've got drawing this. This is actually another line of symmetry because you can see that when I fold it along this blue line, this parabola actually will cover this parabola. So this is the axis of symmetry, the blue line. And that is actually negative line of symmetry or axis of symmetry because the gradient is negative. Alright, so what I'm going to do is, again, clear this because I'll need to show you the parabola quite clearly. What I want to show you now is the equation. The equation of the positive line of symmetry is actually y equals to x, and negative line of symmetry is y equals to minus x, or in fact I might actually use the blue color, so that is color coded. Now for the asymptote, I'm actually going to use the highlighter to show you the asymptote. The vertical asymptote is this line over here. That's the vertical asymptote. Alright? Okay. Just to indicate to you, this is the vertical asymptote. It just means that this part of the parabola will get very, very close to the y-axis, but it doesn't touch it. Same with here. This bit of the parabola get very close to asymptote, but does not touch it. And the equation of the asymptote is actually x equals to 0, or the y-axis. Now, let's have a look at the horizontal asymptote. Alright, I'm going to show you where the horizontal asymptote is. Horizontal asymptote. Now here you can see that as the parabola approaches the x-axis, it actually does not cross it. Same with this part. Alright, therefore we know that the horizontal asymptote is y equals to 0 or x-axis. Alright, now just to indicate that color, blue color is the horizontal asymptote. Next, we talk about the behavior of y equals to 1 over x. So let's have a look at as x approach infinity, what happens? So this is point when x approach infinity. Alright, what happened? Where does y goes to? Y go closer and closer to 0. Alright, but it is on the positive side and is from above the x-axis. So therefore, we should say that y approaches 0 and is on the positive side, approaching from above or on the positive side of the x, above the x-axis. All right, and then what about this bit? As x approaches negative, infinity, what happened to y? Again, it's the same. Y approaches 0, but this time is negative because it's on the negative side of the y-axis, or we call it 0 negative. That positive and negative is telling me whether it is above the x-axis or below x-axis. All right, so now therefore you know as x approaches 0 plus, because it's on this side of the y-axis, so as it go closer, 0 plus, x approaches 0 plus, y actually approaches infinity. Same here, when x approaches 0 minus, right, y approaches negative infinity. So that is actually the behavior of the parabola. We now need to determine the natural domain of the parabola. All right, what we need to do is determine the equation of asymptotes. So you know that the asymptote, let me show you again. These two lines are the asymptotes. So you know one is the x-axis, one is the y-axis. So here, this is the y-axis, which means the equation is x equals to 0. And this one, the x-axis, the equation is y equals to 0. And you know that in this case, the parabola does not cross this point, which is the origin 0, 0. So therefore, the natural domain, the domain of y, is actually y, beg your pardon, is actually x, is such that x is an element of the real number and x does not equal to 0. And the range of y is such that y is a member of the real number and y does not equal to 0. All right, it's very important to know this point here, because I use this point 0, 0, where the two asymptotes intersect. I use it to translate the hyperbola. We are now going to look at the first transformation of a parabola, which is dilating a parabola. So let's consider another rectangle. This time the area is 4 units square. So therefore you know x, y is actually 4, and therefore y is 4 over x. So let's start off. If x is 2, y equals to 2. If x is 1, y equals to 4. If x is 4, y equals to 1. And so on and so forth. What about if x is half? Y is actually 8. And when x is 1/4, y is 16. So if I plot these 3 points, you've got when x is 2, y is 2. When x is 1, y is 4. And when x is 4, y is 1. So therefore, you can see that what I've done is I have actually dilated the parabola. So if I do the same thing as plotting on the negative side, it will look as like this. When x is minus 2, y is minus 2. When x is 1, when x is minus 1, y is minus 4. When x is minus 4, y is minus 1. Therefore, again, you draw this. Alright? Now, looking at the line of symmetry, starting off with the positive line of symmetry. So, what have we got here? Positive line of symmetry, the equation is still y equals to x. Negative line of symmetry, y is still minus x. And then if I actually draw the asymptote, the vertical asymptote is still y-axis. The horizontal asymptote is still x-axis. Now, what is the conclusion you can make? You can see that the domain and range, the intersection point is 0, 0. Intersection point is where it tells me where the parabola will never touch us, will never cross. So, in that sense, by dilating the rectangular parabola of 1 over x, there's actually no effect on the line of symmetry and line of asymptotes. Now, what about the domain and range? Go back. So, we know that in this case, therefore, there's no effect on the domain and there's no effect on the range as well. Now, the next bit. Now, transformation number 2 is the vertical translation, plus or minus d in the direction of plus or minus y-axis. You should recall what you have learned in the quadratics, cubics, or linear. Plus d means move the graph, the shape, or the line up by d, or the parabola up by d. Minus d means move it down by d. Alright, so we are going to look at the effect on the lines of symmetry and look at the effect on the asymptote, the effect of the domain, and the effect of the range. We will do so by looking at the graph of y equals 1 over x minus 2. So effect on the line of symmetry. What happened? If it is plus d, we move up by d. Minus d, we move down by d. Alright. Effect of the asymptote, no change. For the vertical asymptote, but move plus or minus d up or down for the horizontal asymptote. Alright. Effect on the domain, does it change? No, because we have not changed x value, we have not moved anything. So the effect of the domain is no change. It's still x is such that x is a member of real number, x does not equal to 0. Alright, so domain of y. What about effect on the range? Yes, it has changed because we have moved down or up. So in this case, range of y is, actually I should use equal sign. Y is such that y is the member of element of real number. Y does not equals to plus or minus d. Alright? Now, let's look at the third transformation. Now, let's look at the graph of y equals to 1 over x minus 2. First, let's actually draw the line of symmetry in. Alright, this is the positive line of symmetry, and this is the negative line of symmetry. Alright, and then what about the asymptote? So this would be the asymptote. Vertical and horizontal asymptote. Now, this is done. Let's have a look at the equation of positive line of symmetry. What happened here? We started off with y equals to x. Now we move it down. So therefore, is y equals to x minus 2. We have shifted the line of symmetry down. What about the negative line of symmetry? Is y equals to minus x to start off with. Again, has become y equals to minus x minus 2. Now, the vertical asymptote, has it changed at all? No, it's actually still the y-axis or x equals to 0. However, the equation of the horizontal asymptote, you have actually moved from the x-axis down to y equals to minus 2. You move it down. So, the domain in this case, alright, and the range, we look at the point where the asymptote crosses, or the intersection of the asymptote. So therefore, for the domain, we know that domain of y is such that x is a member of R, and x cannot be equal to 0 because the equation of vertical asymptote is x equals to 0. And the range of y is such that y is a element of the real number, and this time y cannot be equals to minus 2. Now, let's go back and answer those 4 questions. Transformation number 3 is the horizontal translation, plus or minus c. It's in the direction of minus or plus x-axis. Remember, it's not intuitive. From quadratic, from cubic, if it is minus c, x minus c, you move to the right. X plus c, you move to the left. Alright, let's use an example. So here, effect on the line of symmetry. What happened? So if we have x plus c, we move the line of symmetry to the left by c units. Alright, if it is x minus c, you move the line of symmetry to the right by c units. Okay, effect of the asymptotes. There's actually no effect at all for the horizontal asymptote, but for the vertical asymptote, move left or right by c for the vertical asymptote. Alright, effect on the domain. There is the change in the domain. So domain of y is now x is such that x is a member of real, element of real, and x does not equals to plus or minus c. And there's no change in the range. So range of y is still y is such that y is an element of the real number and y does not equal to 0. No change. So I better put it down here, no effect. So now we have looked at the three types of transformation. We can now go into determining the equation of a rectangular hyperbola. We are using the example of y equals to 1 over x minus 3. Again, let's draw the line of symmetry. So this is the positive line of symmetry. And then the negative line of symmetry. Negative line of symmetry. And then the vertical asymptote. And the horizontal asymptote. Right. Now, let's answer the questions. Equation of the positive line of symmetry. You can see that it has moved across to the right by 3. Doing so, the intersection of this line is now moved down to minus 3. So therefore, we started off with y. Y equals to x, and when it's moved down is minus 3. So you can see that we've moved the whole line across to the right. And here the equation of negative line of symmetry. We start off with minus x. By moving across to the left, the intersection is then moved out by 3. So it's plus 3. The equation of the vertical asymptote. Vertical asymptote, you have moved from y-axis, which is x equals to 0, to x equals to 3. But there's no change in the equation of the horizontal asymptote, which is y equals to 0. So now again, looking at this point here, for the domain range, the domain of y is x is such that x is an element of the real number, and this time x does not equal to 3. And whereas for the range of y is such that y is an element of the real number and y does not equal to 0. So you can see that moving left or right only, we do not change the range. Now, let's go back to answer the 4 questions. Here, you've got the general form of a rectangular hyperbola, which is y equals to a over x prime or minus c plus or minus d. Alright? As with the quadratic functions or the cubic functions, always assume that there's an a value when determining the equation. Now, let's go and have a look at an example. Here, I've got parabola. You can see that it has been translated. It possibly has been dilated, but we are not sure. So first thing we need to look at is the asymptote. So the asymptote, horizontal asymptote, is actually this line here. And the vertical asymptote is actually this line here. Alright. Now, you can see that the vertical asymptote is x equals to 1. Horizontal asymptote is y equals to 1. Alright, which is telling me that the hyperbola has been moved across to the right by 1, or to the positive x-axis by 1, and up by 1. So therefore, we can start looking at the domain and the range of this hyperbola. We know that this point here is 1, 1. All right? So the domain of the hyperbola would be dx equals to x is such that x is the element of the real number. This time x does not equals to 1. Same with the range of y is such that y is an element of R and y does not equals 1. Then we can actually determine the equation of the hyperbola. So we know the general equation is y equals to 1 over x across by 1, so it's minus 1, up by 1 is plus 1. In fact, it's not 1, it's a. Alright, we need to determine a. So generally, I will use the point where it crosses the axis. So you know that one of the value is 0. Makes life a little bit easier. So if I use 0 minus 1, alright, which is this point here. 0 minus 1. Substitute in there. So we know that minus 1 therefore equals a over 0 minus 1 is minus 1 plus 1. Rearranging equation, bringing the plus 1 to the left hand side, which means we have minus 2 equals to minus a. Therefore a equals to 2. So the equation of this hyperbola would be y equals to 2 over x minus 1 plus 1. That's all you need to do. Alright, that is the end of the lesson.